We know that joining of three collinear points forms a triangle. Now, if we join four collinear points, it forms a figure known as quadrilateral. A quadrilateral is a closed figure which has four vertices A, B, C, D, four lines A, B, B, C, C, D, D, A, four angles A, B, C, D, two diagonals A, C and B, D. Let's understand quadrilaterals in a descriptive way. At the end of this module, you will be able to define quadrilateral, understand angle sum property of quadrilaterals, define and differentiate the types of quadrilaterals, understand the properties of parallelogram, understand the conditions in which a quadrilateral is said to be a parallelogram, understand midpoint theorem. The angle sum property of quadrilateral is stated as the sum of all the angles of a quadrilateral is 360 degrees. Look at the figure. The sum of angle A, angle B, angle C and angle D is equal to 360 degrees. Let's see its explanation. Draw a diagonal and divide quadrilateral in two triangles. Triangle ABC and triangle ADC. Now apply angle sum property of a triangle. In triangle ABC, angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Consider it as first equation. In triangle ADC, angle 4 plus angle 5 plus angle 6 is equal to 180 degrees. It is second equation. Now, if we add equation 1 and 2, we will get the angle sum property of quadrilateral. There are various types of quadrilaterals. First is trapezium. Trapezium is a quadrilateral in which one pair of opposite sides is parallel. See figure A, B, C, D is a trapezium. A, B and C, D are the parallel sides. Second is a parallelogram. It is a quadrilateral in which both pairs of opposite sides are equal and parallel. Also, both the pairs of opposite angles are equal. See figure A, B, C, D is a parallelogram. Side AB equal to side CD and AC equals to BD. AC parallel to BD. Also, angle A is equal to angle D and angle B is equal to angle C. Third is rectangle. It is a parallelogram in which all the angles are right angles. See figure. A, B, C, D is a rectangle. The definition says that it is a parallelogram. Thus, it holds all the properties of parallelogram. There is only one difference, that all the angles are 90 degrees. So, angle A, B, C, D all are equal to 90 degrees. The next type of quadrilateral is rhombus. It is a parallelogram in which all the sides are equal. See figure. A, B, C, D is a rhombus. It holds all the properties of a parallelogram. The difference is that in rhombus all the sides are equal. That is, AB is equal to BD equal to DC equal to CA. The last type of quadrilateral is square. It is a rectangle in which all the sides are equal. See figure. A, B, C, D is a square. It holds all the properties of rectangle. The difference is that all the sides of square are equal. That is, AB is equal to BD equal to DC equal to CA. Let us try to know the properties of parallelogram. First theorem is, a diagonal of a parallelogram divides it into two congruent triangles. Look at the figure. A, B, C, D is a parallelogram and diagonal A, C divides it into two congruent triangles. That is, triangle A, B, C is congruent to triangle A, D, C. Second theorem is that the opposite sides are equal. In the above figure, AB is equal to CD and AD equal to BC. Third theorem is stated as, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Fourth theorem is, in a parallelogram, opposite angles are equal. In the figure, angle A is equal to angle C and angle B is equal to angle D. Fifth theorem says, if in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. The next theorem is, the diagonals of a parallelogram bisect each other. In the figure, AC and BD are two diagonals intersecting at O. According to the above theorem, OA is equal to OC and OB is equal to OD, or we can say that O is the midpoint of both the diagonals. The last theorem is stated as, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Let's view an example. In the figure, A, B, C, D is a parallelogram. Diagonal AC and BD are equal. Then show that angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. To solve this, first of all, observe two triangles ABC and BAD. Prove congruency between them. In triangle ABC and triangle BAD, AB equal to BA, as it is a common side in both the triangles. AC equal to BD, it is given, and thirdly, AD equal to BC. These are the opposite sides of a parallelogram. So, by S congruency rule, triangle ABC is congruent to triangle BAD. Now, take corresponding equal angles of triangles. Angle ABC is equal to angle BAD by CPCT. Now, ABCD is a parallelogram. Thus, AD is parallel to BC. AB intersects them. Angle ABC and angle BAD form interior angles on the same side. It implies the given equation. By solving this, we get angle ABC equal to angle BAD equal to 90 degrees. Now, if one of the angles of a parallelogram is right angle, it is a rectangle. Hence, ABCD is a rectangle. Thus, angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. The condition for a quadrilateral to be a parallelogram is that its pair of opposite sides is equal and parallel. A, B, C, D is a given figure in which A, B is equal to C, D and A, B parallel to C, D. Then, according to the above theorem, we can draw the result that A, B, C, D is a parallelogram. Now, let's understand midpoint theorem. The midpoint theorem is stated as the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Let's see its explanation. Look at the triangle ABC, in which D and E are the midpoints of side AB and AC respectively. Show that DE is parallel to BC. First of all, extend the line DE up to F. Join FC. Observe triangle ADE and triangle CEF. In triangle ADE and triangle CEF, AE is equal to EC, as E is the midpoint of AC. Angle AED is equal to angle CEF, vertically opposite angles. DE is equal to EF by construction. So, by SAS congruency rule, triangle ADE becomes congruent to triangle CEF. Now, take corresponding parts of congruent triangles, that is, AD is equal to CF and angle 1 is equal to angle 2. As AD is equal to CF, we can write DB in place of AD, as D is the midpoint of AB. So, BD is equal to CF and angle 1 is equal to angle 2. These are alternate interior angles. Thus, AD is parallel to CF or BD is parallel to CF. By applying parallelogram theorem, we can say that BCFD is a parallelogram. This result shows that DE is parallel to BC, as opposite sides of parallelogram are parallel. Hence, midpoint theorem is proved. The converse of midpoint theorem is stated as the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. See figure. ABC is a triangle. Observe that if D is the midpoint of AB and DE is parallel to BC, then according to the theorem, AE is equal to EC. Let's take an example. Example. Look at the figure and show that triangle PQR is divided into 4 congruent triangles by joining S, T and U. Solution. As S and T are midpoints of side PQ and QR, by midpoint theorem, ST is parallel to PR. Similarly, SU is parallel to QR. TU is parallel to PQ. Therefore, PSTU, QSUT and STUT U, R, T are all parallelograms. Now, S, T is a diagonal of the parallelogram Q, S, U, T. Therefore, triangle Q, S, T is congruent to triangle U, T, S. Similarly, triangle S, P, U is congruent to triangle U, T, S, and triangle T, U, R is congruent to triangle U, T, S. So, all the four triangles are congruent. Let us summarize what we have learned. A quadrilateral is a closed figure having 4 vertices, 4 edges, 4 angles and 2 diagonals. The sum of all the angles of a quadrilateral is 360 degrees. A quadrilateral in which one pair of opposite sides is parallel is called a trapezium. A quadrilateral in which both the pairs of opposite sides are equal and parallel is called a parallelogram. A parallelogram in which all the angles are right angles is called a rectangle. A parallelogram in which all the sides are equal is called a rhombus. A rectangle in which all the sides are equal is called a square. Diagonals of a parallelogram divided into 2 congruent triangles. The diagonals of a parallelogram bisect each other. Diagonals of square and rhombus bisect each other at 90 degrees. The line segment joining the midpoints of 2 sides of a triangle is parallel to the third side. The line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side.